Okay, hello everybody. Today I'm going to discuss about gallium nitride high efficiency transmitters for wireless communication. And as you'll see during the presentation, we'll see that technology combines with circuit design techniques in order to provide a unique solution or proposition in terms of rather contradictory terms like the linearity and efficiency for base station transmitters. So this is the problem statement. We know that wireless communication is pervasive and wireless communication areas are expanding rapidly. And another problem we see here is that transmitters used in this type of applications are not efficient. So we are wasting most of the power in about 70 to 80%. So that is why it is paramount to look into solutions which are providing efficient transmitters. Moreover, if we look at the wireless standards, we are facing a proliferation of these standards with different frequency allocation bands, different modulation formats. And most of the time, we need to use Class AB amplifiers, which peak their efficiency near the 1 dB compression point. And when we are using the modern modulation formats like OFDM standards, 64 QAM, LTE for newest LTE standards, 4G, we have to deliver very large peak-to-average power ratios. And that is why we need to back off the PA with about 12 dB for linearity reasons. So that is why the efficiency, most of the time, 99% of the time, is around 20%, and that's very inefficient. So these are the design objectives. We want to build a gallium nitride switch mode PAs, very efficient with a CMOS high-speed driver, capable of driving this gallium nitride chip without reliability problems. We want to develop a modulation format which will ensure the linearity, and it is easily reconfigurable. And by doing that, we can relax the specifications for the bandpass filter before the antenna and eliminate, therefore, high Q filters like bulk acoustic wave, resonator, or surface acoustic wave filters, and replace them with a cheap microstrip PCB filter. It was not in the original plan, but we want to provide also a tunable bandpass filter and antenna. And last but not least, we would like to have a scalable solution based on this 10-watt PA and a clear path towards larger powers like 100 watt or 500 watt. So the technology solution comes from MIT. It is a nitride semiconductor solution. And the salient feature is related to the Johnson figure of merit, which is the product between the FT as a measure of speed and the breakdown. And as you can see, the Johnson figure of merit for gallium nitride is about 5 terahertz volt, which is 10 times larger than silicon. And that allows us to have large breakdown at the same time high speed. Moreover, there is an untapped potential for gallium nitride electronics in the sense that we envisage a VLSI kind of technology where digital, analog, and RF, they come together in one platform. And by this, we can eliminate fancy or expensive packages. And as we know, the digital signal processing can be a real enabler for the gallium nitride. So this is the technology. It's a silicon carbide, gallium nitride on silicon carbide. We have only one type of transistor, is the depletion mode N-type. And of course, we have resistors and capacitors. The passive and active components have been demonstrated and measured using different de-embedding techniques. And therefore, we can produce the gallium nitride IC. As you can see here, we have two paths, two power amplifiers with drivers, and for an outphasing kind of modulation format. So this is the demonstrator. It is based on a plain vanilla CMOS IC, which will generate the modulation format, the digital up conversion, and the high-speed driver. It can handle different modulation formats like outphasing PVM and our new modulation format dubbed exponential outphasing. The IQ generation and amplitude phase generation is realized on an FPGA. The gallium nitride and the CMOS are frequency agnostic. They can work in a large frequency range from 800 megahertz to 6 gigahertz. We want power combining in the far field, and that will provide a scalable solution for larger powers. beamforming and beam steering will be possible. And by doing that, we can ensure secure communication because the information will be directive. This is the benchmark where we are comparing our solution with different other gallium nitride solution. As you can see, we are providing the second largest power, but with better efficiency in terms of drain efficiency and peak power rated efficiency. Differentiating factor is the modulation format. So as you can see, if we compare the first, the left-hand side, exponential modulation or exponential outphasing with the PVM, it has a faster decay with frequency and a cleaner spectrum at high frequency. And moreover, it provides also a cleaner spectrum around the high frequency, and therefore, we don't really need high Q filters. So in order to compare the two solutions, we take the LTE spectrum mask for an OFDM 64 QAM, which is the most difficult signal for or modulation for LTE standards. And on the left-hand side, we have the output of the PA, only one choke, with only one choke, and then the filter output, which is a second-order inverse Chebyshev filter. So as you can see, the PVM signals are efficient, but they do not fulfill the spectrum mask for LTE. However, when we are looking at the exponential outphasing, we have the output of the PA without filtering an almost okay spectrum. We are violating the spectrum here and there. And we fulfill the spectrum mask requirements for LTE. So in conclusion, we have shown a state-of-the-art high-frequency MMIC gallium nitride technology and the PDK developed at MIT. We've shown a novel gallium nitride PA with a push-pull driver and amplifier. Each class D PA is driven by a CMOS chip with digital signals. Amplitude modulation is encoded or embedded in the phase signals, so there is no dynamic range problem. We have shown that beam steering and beamforming recovers the amplitude and phase only on the direction of the main lobe, and that shows that we can use it for directional secure communication. And the gallium nitride PA driver and the CMOS achieved 10 watt with 85% drain efficiency and 78% power added efficiency. And last but not least, the CMOS gallium nitride solution fulfills the linearity specs for OFDM 4G standards. Thank you very much for your attention.